Hi everyone. So today we'll continue with the structures of enamel, and the first structure we take today is Hunter-Schreger bands. So what are Hunter-Schreger bands? You can see in this diagram that they are light and dark bands. Okay, they appear in the longitudinal section of a tooth. What is a longitudinal section? I'll explain over here. Just a second. So if I have this tooth over here, right? This is side view of a tooth. Not a very good diagram. Just a second. Right, I have this tooth and I take a knife or a cutter, whatever, and I cut it over here like this. So this will form a longitudinal section. Now I told you that we have many enamel rods in the tooth, right? So there are many enamel rods in going in all the direction. So what would happen is just imagine two enamel rods because they're going randomly in all the directions. I have one enamel rod that was going like this. Okay, let's just imagine this, and I have another enamel rod. It was going like this, maybe. All right. So what would happen that if I when I cut this tooth, right? So these two enamel rods, one, it was cut like this over here. This is called this is cut in this is cut longitudinally. Okay. And then there was this enamel rod, and this was cut transversely. You see the difference between transverse and longitudinal. So this was cut longitudinally, sorry, and this was cut transversely. So the rods which are cut longitudinally, they are called parazones. Notice over here, they are called parazones. And the rods which are cut transversely, they are called diazones. These diazones, they appear light. Okay, so this light bands you see are here. It's these enamel rods. They are cut transversely and they appear light. And these dark bands you see in here, these are these are the parazones. Okay, and they are cut longitudinally. So this is the entire concept of light and dark bands, Hunter and Schreger bands. Now going to the notes. These are alternating light and dark bands of varying width seen under in longitudinal ground section under obliquely reflected light. So this is only seen under obliquely reflected light. Remember that. They are present mainly due to the change in direction of the rods. So you saw that because two rods were going in different direction, this is why the rods appeared. Okay. The dark bands are called parazones and the light bands are called diazones. And I explained to you how they are cut longitudinally and transversely. Okay. They originate at dentino enamel junction and end at some distance from the outer enamel surface. So you can see over here, just a second, I'll erase this. So they originate at dentino enamel junction because that's where the rods originate and they end at some distance from the enamel. Okay. The angle between parazones and diazones is about 40 degrees. So the angle between these two would be about 40 degrees. Other than being optical phenomena, the alternate zones may also appear due to slightly different permeability and different content of organic material. So this is an optical phenomena, okay, because this appears like this under the light. But other than that, the light and dark bands may also have something to do with slightly different organic content, okay. So this might be one band might be slightly more mineralized and the other band may be slightly less mineralized. It is a functional adaptation against masticatory forces. How is that? Because it's due to different direction of the rods, okay? And the more the rods are in random directions or intertwined, the stronger they are as a bunch. So it acts as a adaptation against the forces acting in it. Okay, coming to Gnarled Enamel. What is Gnarled Enamel? It's similar thing. Okay, it is just I'll explain to you first through the diagram. So it is just intertwined enamel. It is present in the cuspal areas, okay, in the high areas which face the masticatory forces the most. It is present in the incisal edge and the cusps. And you see all the rods over here is like more regular, but this is more irregular. Why is that? So let's just say I have this rod. Okay, and they are all going in straight in one direction. Now I have this force acting. What will happen? They are not intertwined. What will happen is these rods will go like this. Okay, they will bend against the forces. But if same rods are intertwined like this, all right. Now if um, a force acts, they won't be pulled apart. So this is how it's a adaptation against masticatory forces. All right, both this and the hunter shaker bands, okay, because they're both due to a different direction of the rods running in the enamel. So it's an optical appearance of the enamel near the dentine in the region of the cusp or incisal edge. The bundle of rods appear more irregularly intertwined. It's a functional adaptation against masticatory forces. Okay, now coming to enamel cuticle. What is an enamel cuticle? I'll explain to you first. What happens is that I had this, imagine I have this tooth. Just a second. I have this tooth. It's still in the gum. It hasn't emerged yet, or it hasn't erupted yet. And now surrounding this is all the connective tissue. What will happen is just now my ameloblasts finished making enamel. So they're done with making all the enamel. Now they want to protect the enamel, because if the enamel comes in contact with this surrounding tissue, it will get resorbed. So what will ameloblasts do? Uh, while terminating the enamel formation, they will leave this last layer. Okay, uh, we will study this in detail in the next video in amelogenesis. So they will leave this layer over here. When the tooth erupts, okay, now the tooth has come up. When the tooth erupts, now it won't be resorbed, of course. In the oral cavity, it's safe, but the membrane, the ameloblast left, it's still there. This membrane, this whole membrane, this thing is called enamel cuticle. Okay. So this is also called Naismith's membrane. It covers a newly erupted tooth but is soon removed by mastication. Alright. Now it is a type of basal lamina secreted by ameloblast when enamel formation is completed. It protects the enamel from resorption by surrounding connective tissue before eruption. So I explained to you both these points, and it is removed by mastication. So it won't stay there for long. What is enamel pellicle? Just ignore this. What is enamel pellicle? It is similar kind of thing. So I have not similar. So it's present on an erupted tooth. I have this tooth, okay, and surrounding this tooth is saliva. Surrounding this tooth is saliva. So what saliva will do? It will precipitate some proteins over here, and these proteins are generally removed by brushing. But what would happen if I don't brush my teeth for 2 3 days? These proteins won't be removed, and this will allow bacteria and microorganisms to colonize this, and when they colonize this, they will form plaque. Okay, they form plaque. What is plaque? If you look at your teeth, most probably you will find in the cervical region, like in the ends, hard to clean areas, you'll find this yellowish deposition. That is what plaque is. Okay, and the this enamel pellicle, which is basically salivary precipitate, it can be removed mechanically, but it reforms within hours of removal. That's why you have to brush your teeth 2 times a day. After 1 2 days of formation, it becomes colonized by microorganisms and forms plaque. So if your teeth is not cleaned for 1 to 2 days, it will form this plaque. Okay, so this is what enamel pellicle is. Now coming to enamel lamellae. Enamel lamellae, it is thin leaf-like structures that extend from the enamel surface towards the dentino-enamel junction. They may also sometimes penetrate into the dentine. They consist of organic material with little mineral content and are of 3 types. So what is enamel pellicle? Sorry, not enamel pellicle, enamel lamellae. Uh, they basically look like cracks, okay, and they are in a way cracks. What are they? They are cracks in the enamel. They originate from the enamel surface, and they are filled with some organic material. Okay, They originate from the enamel surface. They may also go deep down into the dentine. So the type 1 won't type 1 won't go down into the dentine, but type not type 1, type A won't go down into the dentine, but type B and C may enter the dentine. Okay. So what is filled into these cracks? Based on this, it is divided into three categories. And what are the categories? Type A, B, and C. So type A contains poorly calcified enamel rods, B contains degenerated cells, and C contains some organic material. Okay. Now A is generally restricted to enamel. So what I told you, that A won't go down into the dentine, but B and C may actually enter the dentine. It is a site of weakness in tooth, which may serve as a pathway for bacteria initiating caries. So of course this is filled with organic material and this is a crack. So it may serve as a pathway for bacteria to enter the tooth. Okay. So this is enamel lamellae, and they appear leaf-like. I think I mentioned this before. So they appear leaf-like and they appear very similar to cracks. Also there was this point mentioned in the Orbans. Decalcification of ground section of enamel makes possible the distinction between cracks and enamel lamellae. The former disappears while the latter persists. So what I told you, that enamel lamellae and cracks look very similar. Okay. So how do we distinguish? So let's just say this is a crack and this is a lamellae. So my crack has nothing in there. Okay, it's empty space. But enamel lamellae will have some organic material in here. So how do I distinguish between this? What will I do? That I will decalcify the tissue. Okay, so when I decalcify the tissue, everything surrounding the crack will dissolve. And since this is already empty space, so nothing will remain. But when everything surrounding the lamellae dissolves, it has some organic material. Okay, so that will remain. So everything is dissolved. You can see the crack disappeared, but this organic content remains, and this is how we distinguish cracks and enamel lamellae through decalcification. So the cracks will disappear, but the lamellae will stay there. Alright. Now coming to enamel tufts. What are enamel tufts? Enamel tufts are nothing. They are like you see this picture. They are grass-like structures. That's why they are called enamel tufts. And what are they? They are just hypomineralized enamel rods. Basically, enamel rods with low calcium content. They arise from the dentino-enamel junction. They may go up to like 1/3 of the entire enamel height. Okay, and there's one major organic content they have. This is called 13.17 kd protein. So this is one of the major organic component of the tuft. So they are narrow ribbon-like structures. This is how the shape is named, not named, but what it looks like, ribbon-like. They arise at dentino-enamel junction and reach into the enamel 1/5 to 1/3 of its thickness. They consist of hypocalcified enamel rods. Okay, so they are basically hypocalcified enamel rods and contain interprismatic substance. The major component is 13.17 kd protein. Okay. Now coming to dentino enamel junction. What is dentino enamel junction? Um, we know it's the junction between the dentine and the enamel. Okay, but there's just one basic concept, that when you draw your histology diagrams, you would draw it like this. Okay, you can even see that it appears like this is called scalloped appearance. And why does it appear scalloped? So enamel rods has many. It's pitted. The junction is pitted like this. Okay, and why is it pitted? Because when the enamel is formed, so this section above the dentine, there would be ameloblasts. Okay, and these ameloblasts formed enamel. So these ameloblasts were sitting in these pits. Okay, so when it's formed and everything, these pits remain, and that's why in a ground section, the dentino enamel junction, it appears scalloped, and this convexity is always towards the dentine because there was maybe an ameloblast sitting over here when the enamel was being formed. So this is the conceptual part that was involved. Surface of the dentine at the dentino-enamel junction is pitted. The section therefore appears scalloped. Convexities are directed towards the dentine because obviously there was an ameloblast sitting over here, so it will be always directed towards the dentine. The rounded projections of enamel fit into these pits. This ensures a firm hold of enamel into the dentine. So when the enamel is formed, it is actually like embedded into this structure. So this is very tightly bound together. Okay. So this is dentine enamel junction. Now enamel spindle, the last topic. What are enamel spindles? I'll explain the concept first. So look at this diagram. Um, this is odontoblast. Just use this. These are odontoblasts. What are odontoblasts? They are dentine forming cells. So when I had, this is what they look like. Okay, this is the cell, and they have this extension. An extension is also called a process. Okay, so this extension may enter the enamel at the dentino-enamel junction. The odontoblast present may have an extension into the enamel, and this extension is called enamel spindle. Okay, so odontoblastic process which cross the dentino-enamel junction and enter the enamel are called enamel spindles. They are present at right angles to the surface of dentine. So you see they are present at 90 degrees to the surface of dentine. In ground sections of dried teeth, the organic content disintegrates and is replaced by air. The empty space appears dark. In transmitted light, sorry, I forgot to add over here, in transmitted light. So what happens is, what this point is saying is that so I imagine I removed everything. Okay, in the ground section I removed everything, and this organic content will disintegrate. So all instead of this enamel spindle, already only space will be left, and that space appears dark in transmitted light. Okay. So that's it for all the structures of the enamel, and I'll continue with amelogenesis in the next video. If you like the channel, please like and subscribe. And for the notes, you can go to the Telegram channel. The link is mentioned in the description. Thank you.